Yep. Tiger 9-1. Tiger 9-1, watch your 26 abstract, 035.
Well, we have a new addition to the bench. No, I don't mean the two Rygal units. Those are just supporting characters. The star of this is a brand new, well, new to me, Agilent 53220A frequency counter. This little guy I found on eBay, and it was an amazing price. I've been looking for the older model 53132A that we see so much of in videos, and I was looking for one of those, but somehow I ended up coming across this on one of the sales. And so I searched around a little more on these, and I found a sweetheart of a deal the other day. And it was such a good price that I almost didn't buy it because I just wondered what I was getting. But it was not coming from overseas. It was actually in the U.S. already from a seller with a lot of really good reviews, a lot of good feedback on the seller. So I went, okay, I'll try it. And it was a good enough price that if there was something actually wrong, it would have been worth it to either fix it or have it repaired or put back into Cal if there was a problem there. But so far, it arrived really clean. There's a little bit of, looks like somebody had a sticker here, but that's it. Otherwise, it's nice and clean. You can see the Cal date. It was recently, well, not recently, 2013. It was calibrated, so it's a couple years out of date, maybe on that. But that's not really that much time for a current production unit like this. But in any case, it seems to be in perfect working order. I'm just really stunned. Everything seems to work quite well. It's really nice. I've been enjoying kind of looking at this and playing with it. It's easy to use if you want, say, statistics. You hit the math button. I haven't done anything really with this yet, just kind of worked my way through it. I haven't read the manual, but it's all quite intuitive. And with the statistics on, we can see standard deviation, min, max, all of that. And again, easy to use. Really, really impressed with this. Right now it's hooked up to the 10 megahertz reference output of the Rygal 4000 scope here. And you can see it showing a little bit high on the counter here. It's showing 5 hertz high, which is a surprise that it's that far out. And I don't know which one's out, but I would guess that it's probably the Rygal, and that this guy's probably pretty close to right on the mark. But that's one of the funny things. I'll have to get a rubidium frequency standard to hook up to this or something like that, because in the past I've used just this simple frequency generator with the counter input. But, now that I have this, it's kind of like a guy with 2 clocks. Man with 1 clock knows what time it is. Guy with 2 clocks is never quite sure. And now I've got, of course, these 3 devices, and they're not all coming out the same, so I'll get a standard and get this guy checked and everything. But so far, pretty good. So I occasionally need to measure the frequency of some signal like this, but there are other uses for these. So now we need to set up a few things to get this working right. I want to measure period instead of frequency, so hit that, period. Okay, we're set there. Now we need to check the input settings off the channel. For the channel, we need to set the coupling to DC. I've already set it to 1 mega ohm. We'll set the bandwidth limit as well. And now we need to set the gate time, because this is very, very slow. That's why we're set to DC coupling, because we're down in the 0.5 hertz range here. Let's crank this up and go for, I don't know, 10 seconds. And again, that was very easy. All I had to do was hit the gate button and turn the knob. The arrows allow you to select which of the digits you would like to change. And that's it. So now we go back to our frequency and period, and after 10 seconds it should show up with a number. There we go. We got a reading. So I can go into math and turn on the statistics and start to get some data. So I'm going to let this run for a little bit and see how stable the input clock is. Oh, and my connection keeps coming off from my ground. So hopefully I'll continue to get data if I can get these crappy little clips to work right. Well, we now have some data. Not a ton of samples, but let's take a look and see what we got. So after just a little bit of runtime, the temperature in the lab has been stable as well. We're seeing, and it's going to be tough to see on that little screen, 2.2 second is the mean time rise to rise, and so that's 2 sleep periods. And the mean is 2.224, and the standard deviation is 28 milliseconds. That's actually very, very good. A lot more stable than I had expected. Now the peak to peak is fairly significant. There were some pretty big swings. Looks like the max difference in the peak to peak was 71 milliseconds. So a little bigger than the standard deviation, of course, but still not too bad. So the Arduino Pro Mini at 3.3 volts at a stable temperature does have a pretty stable sleep cycle. I'm going to let this run overnight and see if we get a little bit more variation as the temperature in the lab drops, because the lights will be off and I'll have the other gear shut down. Well, the Arduino's been running for quite a while now, and we have just over 1,000 samples. Let's take a look at the data and see how the statistics look. All right, 1,041 samples, 2.220 seconds per cycle. That's from switching the LED on to the next time it comes back on. So that's 2 sleep cycles. Standard deviation is 48 milliseconds. So that's really pretty good. Really pretty good on that. Now there's a peak to peak of 375 milliseconds in spread across those. It's possible that one of these minimums, like there was some sort of a hiccup in the timer, some sort of overflow, but the max was 2.249, which is less than 1 standard deviation above the mean. So really pretty stable. It's had some temperature fluctuation, so we'll include that, but not a lot. Maybe 2 or 3 degrees C, so just a little tiny variation in temperature, I think, down here today. So over the last several hours. So anyway, I'm real pleased. It works. The timer is working great. The Arduino sleep cycle is actually more stable than I thought, and I wouldn't have known that if I didn't have some good way to measure that, and now I do. So this is just a nice little guy. I like this thing. And if you like digits, well, this one's only showing, what is that, 11 digits. Wait for it. There's a digits button. Switch it over to manual digit settings. 15 digits. So if you like numbers, this has got a lot of numbers on it. But of course, there is the difference between resolution and accuracy. So I'm not sure I'll have to look at the data sheet and figure out the accuracy and things like that of how many of these digits are really of any real value to me for most measurements. But yes, you can actually manually set the number of digits. So really neat. And again, very intuitive to use. So I thought it'd be worth checking the power consumption on this thing. With it running and busy counting away, it's pulling 0.22 amps. That is at US voltage 118 volts AC. So about, according to this cheap kilowatt, 16 watts of power. So not much while it's busy running. And now that it's off, it it's pulling 0.04 amps, so very little, basically almost zero. It says 2 watts, it says. Let's check that. Seems like quite a little bit, really, for that. Well, with it unplugged from the kilowatt, still registering 0.03 or 0.04 amps. So, gonna guess that this really doesn't need very much at all in the way of current when it's in standby. When it's on standby there. It bumped up to 0.6 when I plugged it in, and now it's back down to nothing. And turning it on, 0.24 amps. And then once it's up and running and hooked up, counting, it looks like it settles in at about 0.22 amps at US 60 hertz, 120 VAC. And Mike's Electric Stuff did a great teardown of these, so I was just going to take a quick look inside at this thing. To do that, it looks like going to need a Torx screwdriver of some sort, and it looks like maybe a Torx, what is it, about a 20 will do the job. Yep. Alright, so there's the magic for channel 3. It's right here. You can see the little waveguide coming in to the module. And what are the details down here at the bottom? That is part number 53200-66505. That is the option 106 for the 6 gigahertz board. And no, this isn't the signal path blog, so I'm not going to be taking this apart. And as I'm in here kind of looking at the condition in here, it's really pretty clean. This has got a little bit of grime on it, but that's not really much in the way of a buildup. So it probably hasn't had a ton of on time. It's actually very clean inside. A little bit of dust, but just not much at all. Certainly better than most home computers will typically be inside. So pretty surprised at how clean this is. And there she is, all racked up in her new space on the bench.